Today we will continue data types. Today we'll discuss about arrays. As we know, an array is an aggregate of homogeneous elements, right? The same kind of elements, in which an individual element is identified by its position, which we call it as index or subscript in the aggregate, relative to the first element. In the sense, you start with some index. If you start with 0, then with the step value 1, if you see, then relatively you can find the subsequent elements, right? So your array, for example, you have with index 0 starting with 1, 2, 3, and 4. This whole array is being pointed through some name, okay, a single name. Let us say you said array of 5. So with the same name A, you can point this entire memory, and the first element index is 0. If it is 0, then with the step value 1, if you have defined or declared the indices of that particular array, then subsequent elements will be identified relative to the first element position, right? So if I have to find the fourth element, so how can I find the location of fourth element? If I have to find, is equal to, I'll say location of I. I tell you, I can say I minus 1. I can design a formula here, right, Father? If my index is starting with 0, okay, all the time, and if you find this is my first element. First element in the sense it is 0. It means 1 minus 1, right? Second element is 2 minus 1. Listen, you have to identify the subscript. If I subtract 1 from the element, then if I am able to get, then I can probably design a formula like this: location of I equal to I minus 1. Similarly, location of 4 will be what? 4 minus 1 is going to be 3. So 4 minus 1 is going to be 3. So 3 is the position or the index of the fourth element, rather. So this is how we can rather design a formula as well. But then we'll see while writing while implementing this array programming construct, what kind of issues that the language designers have to face. What are its characteristics and operations that have to be taken into consideration? We'll discuss in the subsequent slides. So the design issues associated with the arrays. Here, some of them are mentioned. You can see what types are legal for subscripts. Subscripts are the indices, right? So what kind of values are allowed? As we have earlier discussed as well, and you are well aware of about C arrays. There you have seen the indices. Indices are the integer values, rather, right? So we have taken the indices as integers. So only integers are allowed, like in C++ or Java as well. If you see, only indices are allowed, right? But in some other programming languages like Ada and other kind of languages, where Boolean and enumerated and other kind of stuff also will be allowed as indices. So these are some of the issues. So while language designers have to take care of what kind of subscripts that should be allowed in order to access the elements from that array being pointed through these indices, right? And are subscripting expressions in elements references range check? Do you have a range check? Basically, for example, as I said, if you have an array declared with about 5 elements, then we by default understand that there are 5 elements, right? So, and if you start with an index value 0, then we say that the elements are range with the indices from 0 till 4, rather, right? And if you are trying to access an element being pointed by the 5 index, then that must not be available in it, rather, right? So do you have, the programming language, is it going to check the range of the values, whether it is available as part of the programming language or not. The programming language designer must look after it rather, right? Like in few languages like Java, this is being taken care well worstly, because in Java the index value will start with 0 only. For all arrays, the index value must have to start with 0 only. So then it is clearly understood that when the array is declared of about say 5, the elements will go till up to 0 to 4 only. If I am trying to access an element being pointed by 5th index, definitely it is an exception, which we call it as array index out of bound exception, right? So if you have array reference range checking available, then probably you can raise this kind of exception. Yes, sir. So, but in C it is not available, right? C, there is no fixed value that you start with for the index. We generally start with index 0, but it is need not to be start with 0 rather, right? I can either start with -1. If I start with -1 and step value 1, then probably it's -1, 0, 1, 2, 3 till 3 only I'll get rather, right? If I start with, let us say, -2, I can start even with 1 also, right? In C language, I can start with 1. If I start with 1, then 1, 2, 3, 4, 5. So range checking is not possible in C. There is a language designer left to the user. So this is another kind of issue which has to be looked after by the language designer. When are subscript range bound, as I said, right? If you have like in Java, it is it knows that the index value starts with 0. Obviously, the last element value must be I minus 1. I mean, if there is an ith element, and if I design a formula for ith element rather, right? A location of I equal to I minus 1, I say, then whatever the element, let us, for example, if you are trying to access an ith element, then first you can probably find out the index with the help of this formula, and then compare it with the size of the array, and if this particular value is less than, only then you can probably say that the element is available, otherwise not. So this kind of some small program, of course, is being written as part of the Java compiler in order to check whether that particular respective element is available or not. So this is being looked after at the runtime, because in Java the execution and memory allocation, basically memory allocation, these range checking and all being taken care at the runtime by the operating system. Anyway, some have to. There are some programs who are only when going to check all this can probably let you know that this kind of issues are being available, and it can be raised, right? So in C it is not possible, because you don't have the proper mechanism of fixing it to start with some kind of index. So how can it rather check it with some maximum bound or the larger bound where they have to stop, and then probably raise an exception when a particular user is executing on the same. Fine. So this is another issue, right? Similarly, what does allocation takes place? See, the memory for the array, when you declare an array, memory is going to be allocated. Basically, in C language, it is a static, kind of allocation happens. So if we say A of 10, the memory for this particular array is going to be allocated during the compile time itself, rather, right? Before the runtime. How many elements? 10 element space is going to be allocated. So this is all our assumption that the indexes start with 0, then probably 1, 2, 3, like that till up to 9, rather, right? Fine. So here the allocation of the memory, where it has to be done. Is it at the compile time? Memory allocation is to be done at the at compile time or runtime, right? Fine. So these are issues which the language designer must have to take into consideration, rather, right? So again, when the memory is being allocated either at compile time or runtime, then from where that memory has to be allocated, either from the stack or the heap. There is a difference between heap and stack. Basically, as I have discussed with you probably in the beginning classes, that what is a stack? Stack is a data structure, of course, for which a part of memory being allocated from your preliminary memory, where all stack operations are performed, which is based on last and first order set, right? So for most of functions, recursions, and infix evaluations, conversions, and many of the stuff, of course, rather memory being allocated, operations are going to be carried out at the stack memory. But then there is one heap also you must be having. This is available at runtime. This is open for all. I mean, open for access to all. So this particular memory can be allocated. The memory, if you are trying to allocate it at the runtime, rather, right? So memory you will get it from the heap. Heap is something like some memory reserve, and which will be open to access, available for all during the runtime. So if I am trying to access or allocate some memory to my program during the runtime, I'll go and get it some memory from heap. The advantage of heap is, you can get some memory allocated from this at the runtime at the same time over the same execution. If I want to release the memory which I have occupied with, right? I've occupied with this memory. I want to release it, so I can release it back, so that this memory again can be used by someone else, rather, right? So dynamically to allocate the memory and run dynamically to allocate the memory and deallocate the memory, rather, right? We get it allocated from the heap. Basically, when you are trying to get some memory allocated with the help of pointers, right? How the memory allocation is going to be done during the runtime is with the help of pointers. Of course, we'll see in the subsequent slides when pointer concept comes. So that memory is being allocated through heap, rather, right? So for arrays also, you can get the memory allocated from stack. One part of the memory which I said is being reserved for stack from the RAM, right? So you can get allocated some memory from stack, or else you can get some memory allocated from even heap as well. But in order to get some memory to be allocated from heap for your array, so when that memory is going to be allocated during the runtime, right? From stack, you can get it allocated during both the compile and runtime, of course, right? So these are some of the issues which have to be addressed and taken into consideration. What possible ways the designer is allowing you to get the memory allocated for your respective arrays, right? These are some of the issues which have to be addressed. And what is the maximum number of subscripts, right? What is the subscripts to be allowed could be, what would be the maximum value for that subscript? When you are giving the subscript range, right? So what could be the maximum value of it? Yeah, so if you are having more than, let us say, 27,872, something like this, will it be allowed as an index? So that has to be rather addressed, and then should be taken into consideration by the language designer. Can array objects be initialized? Can you initialize the array? For example, you have an array declared of this kind, to be a file. Can you initialize the array? Okay. Generally, you initialize the array at the runtime. At the declaration time itself in C language, right? But is it allowed after the declaration as well? For example, I give like this, right? 1, 2, 3, 4. In general, in C language, you may have seen, if I am declaring an array, during the time of declaration, if I initialize it, how do I initialize? Equal to, within braces. Within braces, we will keep, we will give the values. So based on the values, automatically the size will be set. So how many values I have given here? Separated with comma 1, 2, 3, 4. Every value separated with a comma will be treated as a separate value, right? So 1, 2, 3. So 4 elements are there. Automatically 4 element size array will be fixed here, right? You need not to mention the size at the time of declaration when it's been initialized. So initialization is allowed in C language in this kind. So similarly, in other languages, in what way it is allowed and out. The language designer has to clarify this out. Or any kind of slices are allowed. I mean, if you have an array declared of a bigger size, let us say 20 and 10 and all, but I don't want to use this entire thing. Can I go for a slice of it? I mean, I want to have only, let us say, 3 rows and then 2 columns from the same which was declared before. I mean, when this was declared, the memory was been already allocated for 20 arrays and 10 columns. But then I want to utilize only for an array with 3 rows and 2 columns. So this is said to be a slice of this one, right? So can these slices are allowed, right? If allowed, in what way? That procedure is available in the programming language. All have to be addressed and then discussed and should be made available and should be made understandable to the user, right? So these all design issues probably we'll discuss associated with arrays in the subsequent slide. Okay. Yeah. First, coming with indexing. So indexing or subscripting, we call it as, right. So how this indexing is allowed in different programming languages. Generally, you can see parentheses are the square brackets are being used. Most of the languages, of course, use square brackets, like C, C++, and all, right? But there are certain languages who will use parentheses, right? Like, for example, Fortran, PL/1, IDA, and all kind of things. These uses the parentheses to declare the array. So, while declaring an array, how the indexing mechanism have to be in place, that has to be addressed by the language designer. Indexing is a mapping from indices to elements, right? So from index to the element. Let us say with an example I have given you before, right? When the array index starts with 0, the location of ith element, I said I minus 1. It means what? This is your index. So the index is being mapped to the respective element I with the help of a formula like this, right? So this mapping process is what basically the indexing is called, right? So array name followed by parentheses, you give the index value list. What is the list of index value that it can carry? Basically in ADA, not only integers it allows even the boolean. Boolean in the sense index value list carries true, false also, right? True, false. Or it will allow enumerated kind of days. Let us say, for example, if it has, then probably it allow Monday, Tuesday, Wednesday, Thursday kind of thing, also as indices rather, right? So it has to specify at the time of declaration what is the list of index values and all, right? 2 points to know about that, indices will be generally the integer values. So if you have an array of size 10 and all, then you say A of 0, A of 1 kind of thing. It means the indices are integers, right? But in other languages that is not the case. For example, in Pascal, any ordinal type is allowed, right? Any ordinal type is allowed as an index. It means it could be an integer, or it could be a boolean, or it could be a character, or it could be an enumeration. It means in Pascal, if you have an array, then the index value that you must be having, it could be true, A of true, I can have A of false. Basically, if boolean is allowed, then that must have to be made clear at the time of declaration itself. I can have some character, if characters, for example, hash, I can have, right? I can have X kind of thing. I can have alphanumeric and numeric and all kind of thing, right? As indices. Similarly, enumeration. Enumeration also will be. For example, if you have a days kind of enumeration, the attribute values of the particular enumeration also can be used as indices. Rather, it means I can have A of Monday, for example, days is the enumerated data which is being declared to be taken as an index for a particular at the time of declaration. Then I can use A of Tuesday like this. Okay, so this is all possible in Pascal. Similarly, in ADA, ADA also basically have integer or enumeration, and of course it includes Boolean and characters as well as indices. Java again will take only the integer type, right? Because as I said, there is a fixed kind of values rather to start with and to be related with rather, right? So in Java, it is more particular about the index value must have to start with 0 only, and with a step of value 1, if I say, then the range of value that I will be having for the indices for the particular array, which can be easily related to the first element. So in order to find an element I location, it is easy with the help of this formula rather, right? This can be fixed for it. C++. In C++, Perl and Fortran do not specify range checking, right? They don't specify the range checking. Basically in array, in C language, you may have seen that if I declare an array of, say, for example, 5 elements, and you may have access A of 6 also, right? But it doesn't have raised any kind of exception or have not prevented you from accessing this rather, right? Because an element, an index which is not in the range that is specified at the time of declaration. Fine. So some languages like ML also will raise an exception and all kind of thing, right? So fine. Then we look at the subscript binding and array categories. As I said, the memory which is going to be allocated for the array, can be done at the compile time or the runtime, or it could be from the stack or the heap and all kind of thing. So in C language, if you go with it, is as I said, a static, right? Static subscript ranges are statically bound and storage allocation is static. And this is going to be done before runtime, that is during the compilation time itself, right? Advantage is efficiency, but no dynamic allocation. You can't allocate the memory dynamically at runtime. For example, in C language, declaration, right? If I don't specify the expression value, it raises an error, syntactical error, integer array. For example, in ADA, this kind of thing is allowed. So where probably you say that, you just mention that it is an array, integer array, you say A, okay. In Pascal also, you generally give it as variable A, or say array, say colon integer, right? It's like this. I'll give you a Pascal example here. Fine. So what happens here? You are just specifying that array. This is an array, integer array. You just saying, right? Variable array. This is integer array. But then you don't specify its size. The size is going to be declared at the time of using rather. You can mention the size before you rather use it. So this is also possible. That kind of allocation is said to be fixed stack dynamic, right? Space efficiency happens because you are not going to specify the space is required for the particular array when you just mention that it is an array. Rather, at the time of utilization or when you are trying to use, before you use, you are going to declare the size with the same. Of course, in C language also this kind of approach is available, but then it is not exactly keeping in view of this space factor into consideration. It is only from the user's point of view this has been made possible, made available for the user. Generally, you declare an array of some 10 size. You don't want to use that entire array. Then you will take another. While reading this array, you are going to restrict it with the help of this size rather, right? So while reading the array, you start your I is an index here or iterator here. So you can start the index value with 0, and then you say a less than ni plus plus. So these elements. Of course, in this the user given the efficiency, but from space point of view, the efficiency is not implemented, right? So array size is declared as 10, but then you want to restrict it to only n. So you have taken another variable which you have read before reading the array. Then you are saying here the user to enter only how many elements? N elements rather, right? Because you are restricting it with n. the iterator, which is giving you the indexing here possible while being read rather, right? So this is also similar kind of this, but it's a simulation kind. I can say it is a simulation of this in C language, but not exactly of this kind. Because space wise, you are not going to save any space, because at the time of declaration when you said 10, memory required for 10 elements are going to be allocated at the compilation time itself for your array. Whether you use it or not, that memory will be associated with this particular array itself. But then you want to utilize only some n elements, means some portion of them. Which is nothing but slice, I can say, right? Before I have discussed slice of an array. So you are declaring an array of big size, but then you want to use a slice out of it, rather, right? So that is possible. That is how you can. This is how you can probably use the slice of an array, which is available in C language as well. But then the remaining memory, which is also with A, will not be released by A to the system, right? So that can be utilized by someone else. It doesn't happen, rather, right? This memory is still being associated with that particular array until the execution of that particular program, right? Only when this release of memory could happen during the runtime, then only slice of the memory is associated with you, and you can say memory efficiency is done, of course, right? It's just a simulation of this kind, which is rather possible in C, I can say. But then exact of that same is not available in it. But then in other programming languages, this kind of approach is available, and this is made available only when if it happens the memory allocation and deallocation during the runtime, right? So kind of category of subscript binding or memory allocation for the array, Fine. So where the memory you are trying to allocate it during the runtime only, right? So when you are trying to get the memory allocated during the runtime, the advantage is the size of an array need not to be known until the array is not being used. It means you don't specify the array size, rather, right? Okay. You don't specify the array size only during the runtime. Okay, only during the runtime, the memory when allocated for the particular array, the user, the program, the system is going to know that how much memory that I have to allocate for this particular array. So if, let us say, user comes to know about the number of elements required for the particular array to be known only during the runtime, so he can wait until the execution time, and based on the input that he has that he was given, he can probably fix the size and then get the memory allocated for the particular array during the runtime. So of course in C language this is possible, but not exactly as part of C it is available, right? You may have studied with alloc.h, some header file you may have studied in C language, alloc.h. This is a header library file. Basically, as I told you, library functions are not part of the programming language, but then by using which you can probably simulate some of the programming constructs and then avail the advantage of the programming constructs and will make your program more easier, rather, right? In alloc.h library file in C language, you have some functions like malloc and calloc. That is what before we said, like resizing the memory during runtime. Of course, with the help of these functions, allocation of memory during runtime for an array, right? Array memory allocation at runtime is possible with the help of the CLO. And over the same execution for the same array, you want to resize it. You want to change the size of the same, so you can use this realloc. Of course, these are all available, but not as part of the program. They are not part of the programming, right? Because they are coming from whom? One library, right? Library. This is given by the outsider, rather, right? So, so stack dynamic kind of approach, you can probably simulate it. You can't enjoy the same like in the way that we probably discussed about it. But some of the programming languages, of course, does have this as part of the programming construct itself. Okay, we'll probably see in the next slides, right? Fixed heap dynamic. It's similar to fixed stack dynamic. Storage binding is dynamic, but fixed after allocation. The memory is going to be allocated, and it's going to be fixed. But also, this is all going to be done during the runtime, right? Binding is done when requested, and storage is allocated from heap, not stack. Like in Java, it happens. Like in Java, memory allocated for all the objects will be done during the runtime only. Only real-time allocation for all the objects. Everything is considered to be object in Java. Even the data types, which are considered to be the weaker type, weaker objects compared to other kind of thing, but the performance has been increased in Java to almost equivalent to the equivalent to the objects. So that's the reason why we say even data types also high performance objects in Java. Fine. So in Java, what happens? This is one way. The other way also, you not to specify the size when you are specifying here. So I just say int a, square brackets. I don't specify the size here. I say new. New is an operator which you have in Java language to allocate the memory during the runtime. And if the memory is being allocated during the runtime, it's going to be done from the heap, right? It will be done from the heap. So new int 10. If I say what happens now? Heap is free memory. The other way I say the free storage, right? Anybody can use it. Okay, during the runtime, and anybody can return the memory back. Also, C++ is a store operator. What you call C++, new and delete the free store operators in C++. Similarly, in Java we have new. So new will allocate the memory required for this particular array for how many elements? 10 elements of integer kind, right? And this is going to be done during the runtime and from the heap, right? The memory is being allocated from heap, right? Fine. So in Java, there is a another advantage that you have is a deallocation of the memory, right? Deallocation of the memory, you need not to do, the system automatically will take care of it, rather, right? You have a memory management module in Java. In Java, you have memory management module. There is an object called garbage in, garbage out. Okay, GIGO, which is part of JVM or Java runtime environment, JRE. Okay, JRE, which is, as I told you, that JVM or JRE is available as part of every operating system, and it is available as part of every browser, rather, right? Wherever you are allowed to execute Java programs, right? So what happens is allocation of memory for objects is your responsibility with the help of new, but then the allocation of the same is going to be done during the runtime itself when it is not in use by the GIGO, by the garbage collector, rather, and then return it to the free storage, right, or heap that can be rather used by someone else again. So Java effectively utilizes the memory. When it requires only, then it takes, and how much is required, only that much it will take. And when you do not require, then you automatically return. It means allocation and deallocation, all that is being done during the runtime, right? So basically, until the program does not come for the execution, nothing is required. I mean, no memory is required for your program. But in C or C++, what is happening? You are allocating the memory before the runtime, that is the compile time. You just reserve. I mean, if you are allocating the memory during a compile time, is what do you mean by it? You are reserving the memory, something like reserving the seat in the train by putting a kerchief in the seat, rather, right? So you reserve the memory if you are allocating the memory during compile time. That happens in C++, right? Okay. So then that cannot be, this reserved memory cannot be used by someone else until you finish your execution. When you will have to start the, you don't start immediately, maybe you will start after a while. So when you start and then finish, until then your program, your memory is associated with the program itself, right? So effective utilization is not happening here. Exactly that is going to happen by the garbage collector, this GIGO. So what exactly it does, it will identify the scope of the object once it finds that the particular object is no more accessible, it is no more in its scope, then automatically it takes that memory, the memory which has been allocated for it, right? It takes that memory and return it back to the what we call heap. So that's what happens. The effective utilization of memory is going to happen, right? These are the different ways in which the memory is going to be allocated for, you know, what you call array when you declare an array along with this. Is another, you know, heap dynamic, which I have already discussed, right? Heap dynamic. Dynamically, you are allocating the memory from the heap, and then you are only, returning back. Of course, in C++, it is available with the help of new and delete, right? And where you are allowed to grow the size of the array, and you can shrink the size of the array. Like in C also, you have simulation of the same. Once you can allocate during the runtime with the help of calloc, and then you can resize it. You can grow or shrink with the help of realloc, right? This is not exactly being provided by the programming language, but then the simulation of the same is possible, right? In C++ also, you have, with the help of these free store operators, available for you, okay? But in some programming language, this kind of facility is available as part of the programming construct itself. We'll see probably in the next slides. Yeah, subscript binding and array categories here. C and C++, arrays that includes static modifiers are static. So array, subscripts are going to be static in C++. C++ arrays without static modifiers are fixed stack dynamic. You have static modifiers are static, as I said initially, when the memory being allocated during the compile time, right? If they are, you are with the help of some outsiders like Calvin functions, you are trying to get memory allocated during the runtime through fixed stack dynamic, then of course, then also the index is of course static here. Other arrays can be stack dynamic here. So automatically the size of this array is going to be fixed as 4. So this is possible. And C++, Java or C#, this is how the initialization is done during the declaration time. Character strings, if you want to initialize, in C++, how do you initialize? Character name equal to, you give the string value. So this string consists of this, basically a string which is given within the double quotes is said to be the string value, right? So string is a set of characters. How many characters you have? 1, 2, 3, 4, 5, 6, 7. So you have 7 characters. So obviously the size of this particular array is going to be 7. Okay. Arrays of strings in C++, you can have array of strings also available, right? Array of strings. I mean, you have set of strings. String is a character array, and then you want to have such set of names. Then it must be array of arrays. So pointer, basically this asterisk is said to be the indirection operator, which is basically used to declare a pointer. It will act as a reference to the memory, right? This asterisk will act as a reference to the memory, and where you have this memory is an array. It consists of set of strings here, right? So you can see one array is Bob. So one array, one string is Jake, and another string is Joe. So what happens automatically? This particular array size is going to be fixed, right? Basically, when you declare a string with the help of a pointer, the memory allocated during the runtime, right? And how it's going to be done based on the number of values that you input, based on which the memory is going to be allocated from the heap. Heap dynamic concept in if you want to see as a programming concept, from a programming perspective, if you want to see how heap dynamic concept is implemented in C language, you can see with the help of pointers, right? String pointers. This, you must have studied while studying the pointer concept, pointer with strings, right? When you declare a pointer, character pointer. For example, let's say name. This can be done like this also with the help of array concept. If I am going with the same, I can say name equal to, I say Sri, okay, double quote. Both are same, right? both are same. But then I'll tell you what is the difference between this rather, right? The difference between this is what happens, the memory allocation for this name is going to be done here during the compilation time itself. How many characters? You have 3 characters, right? For 3 characters, memory will be allocated, and these values are going to be stored. And the last character of the string will always be a null pointer, rather, right? So this is how the name is going to be pointed. But in this case, what happens? The memory will be allocated while you are using it, rather, right? So it just holds the address, and then memory will be available only when you are using it. Okay, that's the difference. Or else, in order to make it clarify, I will rather, and you are trying to read this name at the runtime. How do you read? Through getS or scanf, rather, right? So getS, I say, of name. Now during the runtime, you have read this 3. So what happens at the time of value acceptance? Then it will allocate the memory for the characters that you have read, based on which the memory is going to be allocated here, right? And then once you encounter with some enter character, then it will attach a null character and forward the same, and the address of, let us say, first character is 100. It's going to be returned here, and it will hold the address, right? So through name pointer, name is acting as a pointer which is pointing to this particular memory. This must be made available from your heap only, right? So during the runtime, the memory will be allocated, right? So when you're using pointers, the memory will be allocated. So this memory which is being allocated is heap dynamic, I can say. Through heap, dynamically the memory will be allocated if I am using a character pointer of this kind, rather, and then reading it during the reading the values for the same during the runtime with the help of getS or this kind of function, right? So if I have a pointer of this kind, a character pointer, this is a character pointer, but then you are taking an array. It means this will hold the address of strings, I can say, rather, right? So I have here Bob, Jake, and Joe. So memory being allocated for all of them, of course, right? And by the time it's being used, rather, right? Java initialization. If you see in Java initialization, how the string is an object in Java. As I said, string is one of the built-in data type or a primitive data, possible with the help of different programming language that we have seen here, right? Then what kind of operations that are to be allowed on the arrays is another issue which is to be taken care by the language design. APL provides the most powerful array processing operations for vectors and matrices. Basically, vectors and matrices, which are being used in high performance computing, like long range weather forecasting or aerodynamics and other kind of thing, which are being implemented through array concept itself, right? So in APL, you can see the kind of operations that are being allowed on vectors and matrices, like unary operators, and to reverse the column elements. This kind of operations are being provided as part of the programming construct itself. ADA allows array assignment, but also concatenation also being allowed here. Fortran provides elemental operations. They are between pairs of array elements. You can probably have to access a particular element. You can use operations that are available as part of it. For example, plus operator between two arrays, if you have to perform, the result of the same is going to result as an element, right? Some of the elements of pairs of the two arrays, right? So you can add two arrays and then get the value of the same as an element, right? That is being allowed here in Fortran with plus of the thing, right? Horizontal or vertical. But if I want to have 2 dimensions, I should have, 2 square brackets, right? We have 5 and then 5. Then I say this is a 2 dimension, which is we used to implement matrices and all kind of thing. The first one represents rows and second one represents columns. If it is a matrix, if it is an ordinal system, then probably this will represent the x coordinate and this will represent the y coordinate. Like, okay? If it is a menu system in a hotel, then this will represent the items and this will represent the price kind of thing. Okay, so that way you can probably implement 2-dimensional, or you can have multi-dimensional arrays. Basically, when you go to space, right, the dimensions are thousands, right? Thousands of dimensions. In order to, like, the space scientists, when they are trying to calculate the locate a particular point, they need to make use of thousands of dimensions, right? So how they're going to, locate that point in the space, right, with the help of multi-dimensional arrays, right? Of course, high-performance computing programming languages, will probably provide you this kind of programming constructs, so where they can be possible, right? And coming to jagged matrix or jagged arrays. Jagged arrays means with varying number of elements. You can have an array not completely. You can have one row can be with 3 elements, and another row could be with 2 elements, and another row could be with a single element, like this, right? Fine. So this kind of arrays are said to be the jagged arrays. We'll see with an example in the next slide, right? Slices. As I said, you can have slices of an array as well. I have declared an array of 10 kind, but I'm not going to use the entire thing, right? In C also, I have explained you with one example, right? I have declared, let us say, I have 10, but then I want to restrict it with some kind of size n. So it means you are using the slice of that array, right? For 10, the memory will be allocated, but then you are not using the entire thing. You'll be using only part of it. Slice. A slice is some substructure of an array, nothing more than a referencing kind. So with the help of referencing, you will be able to access it. Feel that the registry is also available in C, of course, right? Unless it is heap dynamic, where probably you will feel the exact way in which you wanted to implement the same can be made available. Slices are only useful in language that have array operations, right? Slices example in Fortran 95, formula translation 95. You can see, for example, I have here a vector, with integer elements and dimension is 10, but then I want to have only 3 to 6. It means 3, 4, 5, 6 with indices 3, 4, 5, 6. A slice of it, rather, right? The remaining means 1, 2, and then here you have 7 to 10. I don't want to use it, right? I want only this, so I can go for it, rather, right? That is possible. Fortran 95. Okay, so this is said to be the slice. Which it is possible in C also, with the help of simulation kind, right? Similarly, for multi-dimensions, it is possible, right? So one example, this example is illustrated here with some diagram. You can see if you have a matrix of 3 by 3, but then you want to use the slice. What is a slice? You want to have 1 to 3 rows, but then out of which only second column. Means this is what you exactly want. Okay, only this particular portion. This portion and this portion you don't want, right? So a slice of this you want to use. Similarly, I use only this slicer, but the memory allocated for you is 3 by 3. But I'm using how much? Second and third rows, and here 1 to 3 columns. So common section of the same will be only this, right? This will be the common section, right? Though you must be saying that 1 to 3 columns I want to use, but this will not be coming under picture because only 2 to 3 rows, 2 and 3 rows, 2, 3 rows. So this is your common section. Similarly, another slice of the same example in the next subsequent diagrams here. You can probably see that. Yeah, this is all about arrays. Then we'll probably start records or structures in the next class. Okay, so I'm stopping the presentation here.